Today we're going to go to section 11.7, which is volumes of pyramids and cones, which is closely related to what you did yesterday with volumes of prisms and cylinders. By definition, a pyramid is a polyhedron with one base that is a polygon. It is named by the shape of the base. So here we have, this is a pentagonal pyramid. The base is this pentagon at the bottom, and the vertex is directly above the center. This is the vertex of the pyramid. This type of pyramid is called a regular pyramid, and most of the pyramids you'll be working with will be like this, where the vertex falls directly above the center of the base. Now, we recall from 11.6 the volume formulas for a cylinder and a prism. Here I have a cylinder with a cone that has the same base and height. The volume of the cylinder is pi r squared h. Here I have a prism with a pyramid that has the same base, and the height would go directly through the middle here. The same base and height. This prism has a volume of base area times height. So the question is, how are the volumes of cones and pyramids related to the volumes of cylinders and prisms? And this video will give us a short and quick look at that. Normally we would do this in the classroom. So these pyramids and prisms have the same base area, and they have the same height. And if you fill the pyramid with water, we're going to see how many pyramids it takes to fill the prism. 1, 2, 3. So each prism had a volume of base area times height. It took 3 pyramids to fill that prism. And we could do that with a pentagonal prism and pentagonal pyramid that had the same base area and height, hexagonal, any different shape. If it takes 3 pyramids to fill the prism, then the volume of the pyramid is 1/3 the volume of the prism. So it's 1/3 base area times height. Same with a cone. We know that the volume of a cylinder is pi r squared h. It's the base area, the area of the circle, pi r squared, times the height. For a cone, it's 1/3 the base area times the height. So the relationship here is 1/3 the volume of the pyramid, of the prism or the cylinder. So when you're doing these problems, we need to, again, be able to find base area and height. And some of them, the base area is simple. This is a rectangular pyramid where the base area would be 5 times 3, 15 square inches. And we want to find the volume. And in this problem, the height is right in the problem. Again, the height has to be a perpendicular from the vertex to the base. So here, volume of a pyramid is 1/3 base area times height. 1/3 of 15 is 5. 5 times 4 is 20. And this is volume, so it's cubic inches. Here, this is a different type of cone. This is a cone where the vertex is not directly above the center. But the key is that we still have the height. The height goes perpendicular to the plane containing the base. So 1/3 base area, pi times 6 squared, times the height. When I multiply this out, I get 132 pi, and my units are meters cubed. Leave your answers in exact form in terms of pi, unless it's one of the couple problems in the homework where I told you to round. In this volume problem, I want to find the volume, and what I have is a prism with a pyramid on top of it. And again, I want you to show your work. I'm going to find the volume of the prism, which is the base area times the height. And then I'm going to add the volume of the pyramid. So 1/3 its base area times its height. And that's the work that you need to show. Write that out. If you want, you can calculate each of these separately. And then you're going to find me your total volume, 448 meters cubed. Here, I have a cylinder with a cone on top of it. The cylinder, we have 5 inches for the height, and this 2 inches is the radius of both figures. So my volume is the cylinder, pi times 2 squared times 5, pi r squared h, plus the cone, 1/3 pi times r squared times its height. And so I'm going to add this together. Oh, actually, hold please. This is not the height. This is called a lateral edge. It goes along the edge of the cone. I need to find the height here. So I have 2, I have the height, and I have 7. I'm going to use Pythagorean theorem to find the height of the cone. This is 4. I'm going to subtract. I get that the height squared is 45. Take the square root of 45, and you get 3 square roots of 5. That is what I need to plug into the formula. Be careful. I obviously just almost missed that. Here, I'm going to find the volume of the cone. So that's 4 times 5 is 20 pi, plus this is 1/3 times pi times 4 times 3 squared root of 5. The third and the 3 cancel out, and I get 4 pi square root of 5. These are not like terms because one has a square root of 5 and the other one does not. So I'm going to leave them like that, and my unit is cubic inches. You may have answers that look like this. Here I have a cube that's 6 by 6 by 6 that the cone has been cut out of. So I'm going to find the volume of the cube minus the volume of the cone. And that 6 is the height because we can see it's the perpendicular length in that diagram. So here 6 cubed is 216. And when I do 1/3 times 4 times 6, I get, that's a minus, I get 8 pi. So I have 216 minus 8 pi, and my unit is cubic millimeters. We can also do problems where we're searching for a missing value. So here the x is the radius. I'm given the volume of a cone equals 1/3 pi r squared times the height. I'm going to simplify this 1/3 times 9. So that says 147 pi, 1/3 of 9 is 3 pi x squared. And I'm going to divide both sides by 3 pi. I get that 49 equals x squared. Take the square root of both sides, and I get that x is 7 centimeters. Over here, I have a pyramid, and notice the base of this pyramid, and again, sometimes it's helpful just to draw the base. The base of this pyramid has a length of 6 on one side and 10 that's opposite a right angle. This is a 6, 8, 10 right triangle. So when I go to find the base area here, it's 1/2 of 6 times 8. So I'm going to do volume, which is 56, equals 1/3 my base area. So when I multiply out this base area, 1/2 of 6 is 3. 3 times 8 is 24 times my height of my pyramid. So I get 56 equals 8x. Divide both sides by 8. And again, this one works out to be 7 meters. So you're going to do the pyramids today, and then next week we're going to combine these and look at surface area as well.